All right, this lesson is from Unit 2, Lesson 3 on terminating and repeating numbers. So the first part of the lesson is having you convert from a fraction to a decimal. And to remember how to do that, you're just taking that numerator and dividing by the denominator. So in this case, you would have 6 divided by 25. So 25 goes into 6 0 times, adding on that decimal. 25 goes into 62 times. 60 minus 50 is 10. Dropping down to 0, 25 goes into 100 4 times. So this is equivalent to the decimal 0.24. In this bottom example, 5 divided by 9, 9 goes into 5 0 times. 9 goes into 50 5 times. Subtracting 45, we end up with a repeating decimal. So for repeating decimals, just make sure that you have that repeat bar above the decimal. So again, to convert a fraction to a decimal, divide the numerator divided by the denominator. To go the other way and to change a decimal to a fraction, I believe in this lesson it explains to write it as a quotient of two integers. That just means that you're writing it as a fraction, and in some of the case they want it to be an improper fraction, so they don't want mixed number fractions. For this first example, 0.28, I can see that this decimal is in the 100ths place, so your initial fraction you would write over 100, and then you would just simplify it. Both of these numbers have a 4 in common, so if I divide out a 4 from each of those numbers, I would end up with the fraction 7/25, and I can see this is a quotient of two integers because there's a numerator and a denominator, no mixed number on the outside. This bottom one, we have 3 6/10 is how the decimal is read. That's how you can write the fraction. So 3 6/10. Whoops. And then you can reduce that fraction. So this becomes 3 3/5. And then to write it as an improper fraction, because they want it as a quotient of two integers, you would multiply 3 times 5 to get 15 and add 3 to get 18. So this would be equivalent to 18/5 as a quotient of two integers. The next part of the lesson is having you go and figure out what a repeating decimal fraction is written as. So this process is a little bit different because it's not as easy to see what that equation is going to be, or what that fraction is going to be, because we have a repeating decimal. So your first step when setting up a repeating fraction or a repeating decimal as a fraction is set it up as an equation. So set it up so that you have x equals the repeating decimal 0.40. The 40 is repeating. So this would be the decimal 0.404040. Your next step is to multiply by a power of 10, and in this case we multiplied by 100 because the repeating decimal was two place values. So we would multiply by 100, the two zeros, because there's two decimal place values repeating. If there were 3 repeating, then we would multiply by 1,000. If there was one number repeating, then we'd multiply by 10. So you're multiplying by a power of 10 where the zeros match the same number of repeating digits in that decimal. So x times 100, we get 100x. 0.40 repeating times 100, it just moves that decimal place two values. So 40.40 repeating. The next step, you can set it up as a subtraction equation where you're subtracting that first equation from that multiplied equation. So 100x minus x gets you to 99x. And when you subtract off 40.40 repeating minus 0.40 repeating, the repeating chunks are what subtract off. So this entire chunk subtracts off with this entire chunk, and you're left with just 40. The last step is to divide, so you get x by itself. So the fraction equivalent then is 40/99ths. And you might see a pattern if you recognize this and you don't go through the entire equation value. If there's 2 digits repeating, then you'd have 99x equaling 40. So the repeating digit is the other number. You can set it up as the fraction 40/99ths. If it was a 3-digit repeat, that 3 digits that are repeating are going to be your numerator, and you'd write it over 999. If you had 0.55555 repeating, that 5 is your numerator, and you'd write it over 9. So just make sure when you're doing the equation that you're multiplying by a power of 10 where the zeros, the number of zeros, match the number of repeating decimals. So as another example, if I have 0.53 repeating and I want to write this as a fraction, the repeating chunk, 0.53, first set it up as an equation. So x equals 0.53 repeating. I'm going to multiply by 100 because there's 2 digits. So times 100 on each of these, I end up with 100x equaling 53.53 repeating. I want to subtract my original equation, and then you end up 100 minus x, you have 99x, and then these two repeating chunks subtract off, so equals 53. This then becomes the fraction, oops, I wrote that wrong, 53, not 55. It becomes the fraction 53/99. And if you check it on your calculator, it should match this repeating decimal. The last part of this lesson is identifying a rational number between two fractions. And there's multiple ways you can do this. Sometimes in the lesson, I believe it asks you to find the number exactly halfway. And in that case, you would want to add the two fractions. Once they have a common denominator, add them and then divide in half. You'll have the number exactly halfway. But if they want just any number between these two fractions, any rational number, you can either convert them to decimals and find a decimal between the two, or rewrite them with a common denominator and then choose a numerator that would fall between the two. So as a common denominator, I see that it's 5 and 4, so I would choose 20 as my lowest common denominator. So that means I'm multiplying this fraction by 4 to get 12/20ths. And then this fraction by 5 would get me 15/20ths. So since this one has a numerator of 12 and this one has a numerator of 15, there's two possible answers. I could have 13/20ths as being between there, or I could have 14/20ths as being between those two fractions. If instead you converted it to a decimal, so again, 3 divided by 5 to get your decimal, that 3/5 is equivalent to 0.6, and 3/4 is equivalent to 0.75. You could choose any number between there. There's an infinite number of decimals between those two. I would just choose a simple one. So 0.6 between 0.6 and 0.75, you could choose 0.65, for example. That would be a decimal, a rational number between those two. So rational numbers means that the decimal stops. It's not a decimal that goes on and on and on and on forever, or it could be a repeating decimal. But you can choose either to write it as a fraction or to choose your answer as a decimal. And there's multiple correct answers, so there's not just one answer for these ones. It's just any rational number between those two fractions.